Hello, and welcome to the Algebra 1 Interim Test Review. We'll be going through this very quickly. If you ever get stuck or lost, just rewind the video. So, for question number 1, which of the following statements is true about the scatter plot below? Well, if we look at the scatter plot, it has positive correlation. And so, as one variable increases, the other variable increases. So as family size increases, the number of loads of laundry increases. And so the answer is A. Now, for number 2 here, it says, using the data plotted on the scatter plot, which equation most closely describes the line of best fit? So if we were to draw our own line in, it would look something like that. So then we would need to calculate the slope and just do an estimate of the slope. And as we do our estimate of the slope, we would see that between these 2 points, you got to look at the numbers. The run is 4 and the rise is 4. So the slope is 4 over 4. And you're going to say, but there was only 2 squares. But look, it's 4 months, 4 pounds. So the slope is 1. Then the other thing we have to look at is the y-intercept seems to be around 7. And so the answer would be A. For number 3, we're going to have to use Desmos. So let me get that up here. Give me 1 second. So in Desmos, we would create a table and we would put the data in. And so you put the data in and it should look like this. And then once we have the data in, then what we want to do is, the first question was to find the line of best fit. And so the command to have Desmos find the line of best fit is y sub 1 tilde m x sub 1 plus b. Oh, 1. And there is our slope and our y-intercept. So we have a slope of around 9.9 and a y-intercept of around 0.405. So our equation for our line of best fit is y equals 9.945x plus 0.405. Let me just double check that. Then it asks us to what is our best prediction for when the line is 7 feet long. And you can do this in Desmos or on your TI-84, is you would take your equation and we would just type in 9.945 times 7 plus 0.405. Oh, didn't get my decimal place there. And we get an estimate of around 70. So our best prediction for the number of surfers on the beach if the wave is 7 feet high is 70 surfers. All right, number 4, more of the same. So once again, we're going to bring up Desmos and put the data into the Desmos. So once again, to bring up the table, you hit the plus symbol, hit table, and then you input the data years since 2000. And I'm going to go ahead and put the data in. So if we put this into Desmos, we get a scatter plot that looks like this, looks like some kind of linear correlation. And so then we once again use our command line, y sub 1 tilde m x sub 1 plus b. And why am I having trouble here? Okay, use a capital Y. And there is our line of best fit. So, once we have our line of best fit, we then just write the equation down, which is y equals negative 0.1967x plus 6.88. Actually, I should just go to 3 decimal places. So 1.97 and 6.889. Round to the nearest decimal place. Now, the only tricky part here is that these numbers are years since 2000. So when we want 2010, what we are going to put into the equation is not 2010, but just the number 10, because 2010 is 10 years after the year 2000. And if we do that on our calculator, we get an answer of 4.919. All right, so that's it with the line of best fit. Now we're just moving into graphing lines. So the first thing that asks us to do is to calculate the slope of each line given the graph for 2 points. So here we're given the graph. So to find the slope, you pick 2 points on your line. There's 1 point, there's another point. And then we look at, okay, what is the rise? And the rise is -2. And what is the run? 3. So the slope is rise over run, or the slope is -2/3. For this one, we once again pick 2 points. And the fun thing about this is it doesn't matter what points I pick. The rise is 6 and the run is 2. So the slope is 6 divided by 2, which is 3. For C and D, you need to use the formula for finding slope, which is the difference in the y's over the differences of the x's. Remember, that's where you measure change in math with subtraction, so the change in y over the change in x. I strongly recommend that when you do this, you write in these so you can track what you're doing. So this is 3 minus -3 over 8 minus 8. And I will get 6 divided by 0. Now, we are not allowed to divide by 0 in math class, so the slope is undefined. For B, we do the same thing, x1, y1, x2, y2. So this time it's 2 minus 2 over 9 minus -3, which is 0 over 12. And 0 divided by 12 is 0. If I take 0 and I split it 12 different ways, it's still 0. All right, for this, number 6, straightforward. identify the slope and y-intercept for each equation, and then graph the line. So remember, y equals mx plus b. Slope-intercept form says that m, the number in front of x, is the slope, and b, the number added or subtracted to the back, is the y-intercept. So the slope is 3/5, and the y-intercept is 2. So in order to graph this, remember that slope is a pattern, but the y-intercept is a location. So you start in a location. The y-intercept is 2. And then the slope is 3/5. So we would rise 1, 2, 3, and we'd run 1, 2, 3, 4, 5. And then we would take a ruler. We draw a straight line through the points. And we put arrows on the end because the line goes on forever. Now, B is a little tricky, but it's important to remember that if there's no number in front of the x, the implied number is 1. If there's no number added or subtracted to the end, the implied number is 0. So the slope is -1. The y-intercept is 0. And so we start at 0, and then to change a whole number into a fraction, you just write it over 1. So this is down 1 over 1, down 1 over 1, down 1 over 1. The pattern goes both ways. Take our ruler, draw a straight line, put arrows on either end. For C, the slope is -3/4. The y-intercept is 3. So you'd start at 3, always start with the y-intercept, and then follow the slope pattern, down 3 over 4. And then we get a ruler. We draw our straight line, and we put our arrows on. So if you're given an equation in slope-intercept form, that is how you graph it. Now, we have two specialty cases here in D and E. If you see y equals 2, that's just a horizontal line through 2. If you see x equals, then that's always going to be a vertical line through the value. So for this one, for D, the slope is 0 and the y-intercept is 2. For E, though, on a vertical line, the slope is undefined and the y-intercept is not applicable because the line never crosses the y-axis. For this last one, we're going back. Slope is 2/3. Y-intercept is -2. So we start at the y-intercept, then we follow the slope pattern down 2 over 3. You can go the other way, up 2 and back 3. Remember, lines with negative slope go down. Lines with positive slope go up. So let's look into this one and see if we can't match these up, knowing what we know. Whoops, sorry. So, first of all, let's look at A. A has a positive slope, A has a negative slope, -3/2 and a y-intercept of 2. Well, the y-intercept of 2 doesn't help us because they all have a y-intercept of 2. So which one has a slope of -3/2? Well, if we start here and go down 1, 2, 3, and over 2, so that's A. Here, we go down 1, 2, and over 3, so that's a slope of -2/3. So that's C. For this one, we start at 2. For number 3, we go up 2 and over 3. So that's a slope of +2/3. So that's D. And for 4, we go up 1 over 2. So that's a rise of 1 and a run of 2. So this is B. Now, there's a couple different ways to attack number 8. You could plug in 0 for x and y and find the intercepts. You could bring it up on Desmos and look at what are the x and y intercepts. And I'll just show you how you do that real quick. Is you can bring up the equation in Desmos. We'll clear out what we have in Desmos here real quick. This is the last problem we did. Clear it all out. Go back to home. And let's just pick one of these. So I will do A. A says x plus 3y equals negative 6. And if we look at that line, it has an intercept at negative 6, 0, and 0, negative 2. That is not the equation here on the board. That is not A. And you could do that for all the lines. That is a legitimate way to solve the problem. Or you could try plugging in, let's do C. I could plug in 0 for x, and that means y. That gives me a y-intercept of negative 3 because y equals negative 3. So the point 0, negative 3 is on that graph. Well, that's promising. And then if I plug in 0 for y, I get 3x equals negative 3. Divide both sides by 3, and I get x equals negative 1, which means the point negative 1, 0 is on the line. And that's those 2 points. So C is the right answer. So you can use Desmos. You can find the intercepts. There's several different ways to attack that problem. Here, for number 9, A and B, once again, finding the intercepts. So the y-intercept is right here, negative 3. The x-intercept is right here, negative 1. The slope is down 1, 2, 3 over 1. The slope is negative 3 over 1, which is negative 3. For B, the y-intercept is 2. The x-intercept is 3. The slope is negative 2 over 3. All right. What are the slopes of the lines parallel and perpendicular to the lines? So the rule is parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. And reciprocal just means you flip the fraction. So for 10a, slope of parallel lines is negative 4. Perpendicular slope is 1/4. For B, parallel slope is negative 2/3. Perpendicular slope is 3/2. Just flip the fraction and change the sign to do perpendicular. Parallel slopes for this one is 1/5. For this one, flip the fraction, make it negative, and you get negative 5. All right. Number 11. How would the parent graph y equals x be transformed by graphing 3 equals x? So we change the slope, and the slope is changing the slope either stretches it or compresses it. When we increase the slope, we compress. When you decrease the slope, you stretch. When you add or subtract to the end, that's the shift up or down. So this number 12, how would the graph of the parent function y equals x be transformed? If we subtract 4 to the end, it's going to be shifted down 4. Here, this is going to be stretched because we decrease the slope. 1/2 is less than 1. All right, so for this one, if the parent function y equals x, oops, let me see if I can get my y equals x graph there. So this blue line is y equals x. That's this. So how was the graph they gave us transformed? Well, it was shifted down 2. And if I don't know if they asked for this, but we would say the new equation is y equals x minus 2. How was the parent function? So y equals x, once again, looks like this. And so the graph was, the new slope is 2, rise over run, so it was compressed. Slope was increased. If you have any questions about any of these problems, please ask your teacher, and good luck on your test.